Hi Year 10, back again with the second part of ionic bonding. This time it is to do with the ionic compounds. Now ionic compounds form giant ionic lattices, and this is where you have a regular repeating pattern of ions within the structure. So from my diagram here you can see that we've got positive, negative, and that creates this giant ionic lattice with these strong electrostatic forces that work in all directions, which give a very, very high melting and boiling point, but also give a very, very strong structure. Now they are also solids, and they have that strong electrostatic force of attraction between the ions. So this is all your general information that you need to know about ionic compounds. Now, the questions on exams come down to the two key things that we've talked about for every single one of these structures in bonding. In the bonding module, it's come back to electrical conductivity or thermal conductivity and whether they have a high melting and boiling point. And these are your standard questions. And these are the questions, the type of question that you will see on your assessment on Tuesday. So it's important that you know these model answers really well. Now, it is up to you to learn them because I'm not telling you what is coming on. I'm giving you the general idea of the things that you have to come back to every single time. And if you do a good job of learning where you use the correct vocabulary now, it's not going to be so difficult in year 11 when you've got to learn these things again, or revise these things, I should say. You should already know them. And we'll start with electrical conductivity. And again, it came back to a picture. So when we were learning about the electrical conductivity of ions, we drew a very simple picture. Now this is going to play a big role in another module that you will see on your exam. It's only the first question, and again we haven't covered it, so if you do some additional revision on electrolysis, excellent. But if you don't, please don't worry too much about anything that we have not covered yet. I'm not worrying at all. I'm focusing on bonding, I'm focusing on some of the math we've covered, and I'm focusing on the reactivity down groups and some of the general knowledge that you should have already. Now, this is your giant ionic lattice, and what we said was in order for them to be able to conduct electricity, they have to be free to move. And to do this, we have to make them either molten, which means we melt them, and they turn into a kind of liquid structure, and then we've got to dissolve it, so the addition of water, and make that aqueous solution. Now, once this happens, once you've done this to the ionic compound, the ions within the compound are then free to move. Obviously, they would be in a liquid structure, but this gives the idea, and it's the thing I told you to come back to, of the fact that they're now broken up and they're able to move. So, solid ionic compounds cannot conduct electricity. And this is because of those strong electrostatic forces of attraction between the ions. It doesn't allow the ions to move freely. Now, in order to allow them to conduct electricity, you will need to either melt them or dissolve them. So therefore, the ions are free to move and can carry a charge. And I know we've been through that quite a lot, and it's something that when I question you in lessons, it rolls off your tongue. Now's the hard bit. Can you apply those model answers and those key ideas to the correct questions in an exam? And that's why students find chemistry more difficult, because if you don't know your model answers, you're not going to get that vocabulary correct, and you're not going to get those marks for things that you do know about. Now, the next thing to talk about, or the next thing that we're considering, is those high melting and boiling points. So ionic compounds have high melting and boiling points. And again, it comes back to what needs to be broken in order for something to change state. So, for example, in a solid structure, and you learned about your particle model, probably in year 7, you would draw a solid, you would draw a liquid, and you would draw a gas. Now, we teach you lots about those structures and which has the most energy, and the fact that these are tightly packed and these are loosely packed, and the fact that the gases move freely. The thing that we haven't mentioned as much, and something which I mentioned in the year 7s, is between these particles, which could be molecules, there are those invisible forces. And these invisible forces get weaker as you change state. So in a gas, the forces are the weakest. In a solid, they're the strongest. So in an ionic compound, we have strong electrostatic forces of attraction between the ions. and they require a large amount of energy to overcome. Now, the other thing I want to point and I want you to consider is always state the obvious. In any of these questions, you need to state the obvious. The obvious being that these are giant ionic compounds, or they have giant ionic lattices, or they're made from regular repeating pattern of positive and negative ions. So in all of this, you must state the obvious. Once you get your model answers down, and once you get the key words and the type of force responsible for each type of bonding, these questions become very easy, and as you found out in the booklet, very repetitive. Good luck, year 10. Next video will be covalent bonding, covalent structures, and the structure and property of diamonds.